I just want to take a second to show you guys another way to do that first problem. So we had y squared equals x, and I'm just showing you this. This is the way that I learned it, how to use implicit differentiation. So each problem for at least the first couple, I'll do them in two different ways, and then I'll kind of let you guys choose what you are more comfortable with. So if you don't want to use like what they said about using the chain rule, this is the way that I learned it. So when you are taking a derivative, they say with respect to x, but when we're taking a derivative of y, I'm going to take this how I normally would. So that's just going to be 2y. And then because we took a derivative of y, I'm going to say times dy. And then when I take a derivative of my x, derivative of x is going to be 1. But because I took a derivative of x, I'm going to say dx. And now I'm just going to solve for dy dx. So all I'm using here is algebra to solve for dy dx. So 1, I'm going to have to divide by dx on both sides. And then second, I would have to divide by the 2y to get the dy dx by itself. So now I have dy dx is equal to 1 over 2y. Now, I think there's some problems that can be more challenging that might not work as well doing this method, which is why they show you the other one. But for the most part, you will be able to use implicit differentiation this way. And if I know that there's problems like that coming up, I'll kind of let you guys know, and you should be able to start distinguishing when you would be able to use this method and when not. Okay, so we talked about, so in the previous example, we differentiated with respect to x, so using that first method, and yet the derivative we obtained appeared to be as a function of y. So not only is this acceptable, it is actually quite useful. If you look on page 164, there is a graph that looks like a sideways parabola, something like this. And they say this graph, for example, shows that the curve has two different tangent lines. If we were looking at, let's say this was 1, 2, 3, 4, x equals 4. So we would have a tangent line up here, and we have a tangent line down here, and they're both different. So one at the point 4, 2, they say, and the other at the point 4, negative 2. Since the formula for dy dx depends on your y value, our single formula gives the slope in both cases. So implicit differentiation will frequently yield a derivative that is expressed in terms of both x and y, as in the next example that we're doing here. So example 2, finding the slope on a circle. Okay, so find the slope of the circle x squared plus y squared equals 25 at the point 3, negative 4. So if we were going to use this without implicit differentiation, we would have to rewrite our circle in terms of y. So we would end up getting this square root of 25 minus x squared and the negative square root of 25x squared. So that's a pretty nasty problem to be dealing with. So the point 3, negative 4 lies on that second graph. So we would have to, 1, change it to this form, and then we would have to figure out which of these goes with the point that they're asking about. So that first equation is dealing with the top of a circle, which that's terrible, and the second equation is the bottom half. So if you think of 3, negative 4, that's going to be 1, 2, 3, 1, 2, 3, 4. So that's down here. So we're dealing with the bottom half of the circle. So that's why we're using the second equation. And again, I'm not using implicit differentiation here. I'm just showing you how difficult this is at first, and then I will show you how to do it implicitly and how much easier it is. So first off, we need to think of this as, probably easier to think of this as negative 25 minus x squared to the 1/2 power. Okay, So now I need to use the power rule and the chain rule. So I'm going to bring that 1/2 down. So y prime is going to be equal to negative 1/2, leave the inside alone, to the negative 1/2 power times the derivative of the inside, which is going to be negative 2x. Okay, and now simplifying this. This is going to be negative 2x over negative 2, so those will cancel out, square root of 25 minus x squared at the point 3, negative 4. So if I plug in, this is y prime or dy dx, however you want to think of it. If I plug in that 3, I'm going to get 6 over 2 square root of 25 minus 9. That is square root of 16. 4 times 2 is 8. So I'm going to get a y value of 3/4. So my dy dx at that point is going to be 3/4. Okay? So that's my slope at 3, negative 4. So at that bottom part of the circle, that's the slope there. Now, if I'm going to use this with implicit differentiation, then I need to say we're finding dy dx. So this is going to be 2x dx plus 2y dy equals 0. So from here, I need to move some stuff over. So what I need to do is I'm going to minus 2x dx minus 2x dx. Once they're on different sides of the equation, because I need to be able to divide to get dy and dx on the bottom. So this whole thing is gone. So I'm going to have 2y dy is equal to negative 2x dx. Divide by dx, divide by dx, divide by 2y, divide by 2y. And now I have dy dx equals negative 2x over 2y. So remember, what point we were interested in was 3, negative 4. So I just have to plug in those values. So that's going to be negative 2 times 3 over 2 times negative 4, which negatives and 2's cancel out. So again, I get 3/4. So this one was a lot faster than what we did before. And then sorry to add time, if you're good with that, you can skip the rest. I'm just going to show you how to do it the other way again, so the way that they initially showed us how to do it. So again, we have x squared plus y squared equals 25. Now we're taking a derivative with respect to x. So when we take the derivative of x, we don't need a dy dx on it. So if I take the derivative of x squared, that's just going to be 2x. When I take the derivative of 2y, since I'm taking it with respect to x, I need to get this dy dx piece. And then again, still equals 0. Now minus 2x, minus 2x. So we get 2y dy dx is equal to negative 2x, divide by 2y, divide by 2y. And for this problem, this one was even faster. So then we have dy dx equals negative 2 over 2 x and y. So then again, that's going to be negative 6 over negative 8, which is positive 3/4.